Hey, sixth grade. Today is Wednesday, April 8th. We will be doing Amplified Lesson 2.2 in our magnetic fields unit. Just a reminder, or actually an announcement I want to make. It is your spring break week starting tomorrow. So you will not have any lessons due for Thursday. You won't have any assignments for Friday, Saturday, or Sunday, and then Monday as well. So when you come back to Google Classroom, just remember the next assignment that you'll have will be assigned to you on Tuesday. And I'll send you all an email, a message on Dojo as well about that reminder. So yeah, without further ado, let's go ahead and get started. So today we'll be doing lesson 2.2. Go ahead and find yourself on Amplify by clicking that link there. And on Amplify, we'll begin with our warm-up. So if you click on the warm-up, it's going to open up this page right here. Last time for homework, you looked at that simulation where we were like engineers and we built different pieces of a machine. So looking at this photo right here of this machine, you're going to answer these three questions. What part of the system stores potential energy? What part of the system has kinetic energy? And if an object has kinetic energy, what must it be doing? So I want you to go ahead and pause the video, take about 5 minutes, 10 minutes to go ahead and answer these three questions. And then when you're done, go ahead and hand them in and hit play so we can continue the lesson. All right, so by now you should have answered questions 1, 2, and 3. And don't forget to hit the hand in feature right there. We're going to go ahead and jump into the lesson a little bit. So using our tab 2, we're going to find ourselves on this page. And I'm going to use the PowerPoint here for a second. Our investigation question for today's lesson is how can magnets cause objects to have kinetic energy? So we explored this a little bit last lesson, and we'll continue with that today. What is kinetic energy? I just want to remind you, it's the energy something has because it is moving. So like again, this kid sliding down the slide, because he's sliding and he's moving, that means he has kinetic energy. So we're going to go ahead and jump into page 2. Every time we do a reading in class, you have to remember that we like to go back and reread it. So you're going to do exactly that just now. The article is here, and you're going to go ahead and reread the sport that you read yesterday. So the 4 sports that you could have picked were skydiving, snowboarding, gymnastics on the trampoline, and then power blocking. So whatever you read yesterday, I want you to go ahead and take about 15 minutes to reread that. And then I want you to go ahead and answer this question here on the side. Where does the kinetic energy people get during the sport come from? So again, reread, pause the video, take about 15 minutes, and then answer this one question here. And then you can go ahead and hit play when you're done. Okay, so by now you should have reread that article. I still have my annotations from the other day, so you should as well. But regardless, this question should be answered. If you aren't done, you need a little bit more. There's the definitions right there for you. But we're going to go ahead and jump into Activity 3. So Activity 3 is a hands-on little portion of the day, and I know that you do not have the equipment that we usually do for science class, but I brought some home, and I'm going to do the little example for you. So real quick, I'm going to go ahead and stand up here, and I'm going to bring my first little piece into this screen right here on my chair. So in front of me, I have a bouncy ball, and we're going to use this to give a good example of what potential and kinetic energy look like. So for example, if I were to hold this here, and it's staying still, a lot of you are going to go ahead and say that this has what, potential or kinetic? Potential, good. So this has potential energy as it stands here, or it stays still. And I want you to go ahead and let go, and let's see what happens. So after I let go of the bouncy ball, what happened to the bouncy ball? It fell. So as it fell from my hand, it turned in from potential energy into kinetic. Now my question for you is, what was the force or what caused this bouncy ball to have kinetic energy? What caused it to finally gain kinetic energy? There's 2 answers that you might have thought of. Number 1 is you could say my hand, but really all I did was let it go. So that wasn't necessarily what caused it to have kinetic energy. What caused it to have kinetic energy instead was gravity, because gravity went ahead and took that bouncy ball as it was let go and brought it down to the ground. What we call gravity and a bouncy ball like that is a system, and we've used that word before here. So a system, remember, is pieces that work together. We're actually going to use that word here on this page. And I'm going to show you a couple other examples that I want you to observe and tell me what is the system, the two parts, that causes that object to go from potential to kinetic. So I'm going to go ahead and switch screens here real quick. And on this screen I have a few different objects. I have two magnets, weak magnets. I have two strong magnets. I have my bouncy ball. I have a little, they call it a little pom-pom ball, and then a spring launcher. So just remember that spring launcher has a spring inside, just like that. What I want you to do is I'm going to go ahead and do a quick experiment. You're going to fill out this box right here as I'm doing it for you. So I'm going to show you two more examples of a system, and I want you to go ahead and watch and then answer this question. So going back to this screen, let's go ahead and switch. So the first two examples I'm going to show you are not going to be with magnets. I'm actually going to move these magnets away over here. The first thing I'm going to show you is using this pom-pom ball. I'm going to go ahead and take this rubber band that was on my wrist, and we're going to go ahead and set it up like this. So right now, you may not be able to see this, but what does this pom-pom have? Right, as I pull this rubber band back, what does this pom-pom have? Does it have kinetic energy or potential energy? So at this very moment in time, it has potential. It's not moving, it's sitting still. And when I let go, it went ahead and shot forward. So what happened with potential energy is when you let go, it turned into kinetic. So what are my two parts of the system here? One part is my pom-pom ball. The other one is my rubber band. And what happened is the force of my rubber band caused the potential energy of the pom-pom ball to turn into kinetic. I'm going to show you another example. So like I said, we've used the spring launcher before. I'm going to go ahead and set it up as such. So right now, what does this pom-pom ball have? It has potential energy, right? I went ahead and pushed the spring in, and when I let it go, what's going to happen? That did not work out as I wanted it to. See, let's go ahead and try it. There we go. So what happened was after I let go of the pom-pom ball, it turned into kinetic energy, excuse me. And so the two systems in place here is a pom-pom ball and a spring. And what caused these pom-pom ball to turn in from potential to kinetic was the force from the spring, right? So after you have force wound up on the spring, you let it go, and the pom-pom ball will fly. So those are a few examples that you are more than welcome to use here on this tab right here. So where it says System 1, name the two parts of your system. You're going to go ahead and pick any of those examples I just used. So you can use the bouncy ball and gravity. You can use the pom-pom and the rubber band, or you can use the pom-pom and the spring. Whatever you pick, you're going to tell me those two, and you're going to describe what happened. So when was there potential energy in the system? When was there kinetic energy in the system? There's two more boxes we have to figure out, and we're going to be doing this with magnets. So what I want you to go ahead and do is real quick, I'll switch the screen, and I want you to once again observe. So over here on this screen, let's go ahead and wipe away our materials, bring out the magnets. I got two magnets. Now our investigation question is asking about magnets and kinetic energy. So what happens when I have magnets like this and I hold them real close? I want you to go ahead and guess, what do you think is going to happen when I let these two go? Right, they're going to attract. And you knew that because there's two poles on opposite sides. So at this point in time, right here, when I'm holding these, is this kinetic or potential? Good, it's potential. And when I let it go, what happens to the magnets that brings them together is they both get kinetic energy. So we're thinking about what is the force that is causing these magnets to go from potential to kinetic. In this box here, the two systems that are in place are, number one, your magnet and magnet 1 and magnet 2. And so thinking about as they were close together, what happened? Tell me about the kinetic energy after those two magnets, the system, was just let go. Box 3, we're going to use magnets again. So this time over here, I got two strong magnets, and I'll switch screens, I apologize. I'm going to go ahead and hold them close together like this. I want you to go ahead and think to yourself, number one, what kind of energy is this? Go to its potential, because it's not moving. And number two, what do you think is going to happen when I let them go? Well, they're going to get kinetic energy, and what are they going to do? They're going to actually be pushed apart. So again, I'll show you when I hold them too close together, there's potential energy. And what is causing them to move? Well, that's what we're trying to figure out. So what exactly is causing these magnets to go ahead and split apart? What causes them to change from potential to kinetic? That's really what you're trying to go ahead and answer in this question. So in question 3, go ahead and watch those two magnets again, those small ones, the strong magnets, and tell me what are the two systems in place, and then describe for me what happened when there was more potential energy in the system and when there was kinetic energy in the system. So how did we get from having a ton of potential to having a lot of kinetic energy? So go ahead and pause the video. Make sure you finish these 3 boxes if you haven't already. And then when you're done, go ahead and hit play so we can continue on through the lesson. Okay, so by now you should have picked, one of those 3 examples from the beginning. You should have talked about attracting magnets here and repelling magnets here in system 3. What's great is we're going to go ahead and jump into our PowerPoint. I want to help you give some context as to what's going on. So as we think about our problem so far, what we're seeing is there's an increase of speed. And so what is the kinetic energy here? Well, it's the speed, right? So as we see, Monday had about 80. We can call this like a good amount of kinetic energy. Tuesday it had more kinetic energy. Wednesday it had the most kinetic energy of all 3 days. You've seen this picture before. It's actually in the reading that you've been looking at a lot. So every single sports article has this picture. And what we're looking at is on the left side, there's a system where there's a ton of potential energy and it's stored, right? So potential energy can be stored. And then when a force is applied, it's converted from potential into kinetic. And so all of this goes down and all of this goes up, right? So what kinetic energy comes from is actually the potential energy of a system. What is potential energy, you might ask? It's the energy that is stored in an object or system. So again, potential energy is stored. That's a question you're going to have to know for later. And then what we're seeing is when potential energy turns from kinetic into kinetic, it's actually converted. You may have heard of this word before. This picture is, sometimes you might have a file or a picture on your computer or phone and it'll ask you to convert it. So what that means, it's going to change from one type to another. So here, what's happening from potential energy into kinetic? Well, it's converting. A force converts potential energy in the system to kinetic energy as the object moves. Our key concept that we kind of picked up from doing the reading and both the experiment is that a magnetic force can convert potential energy stored in a magnetic field to kinetic energy. So what is causing magnets to go ahead and have kinetic energy? It's the stored energy in its magnetic field, right? The reason why those magnets, when they let go, are repelled or attracted is because there's potential energy in their magnetic field. Now, I know that was a lot of kind of conversations to go ahead and discuss, but I want to go ahead and move forward to the end of the lesson. So taking what we just picked up, using this PowerPoint for help, we're going to go ahead and jump to our homework assignment. On the homework assignment, it's asking you to explain about magnets and kinetic energy. So what we've been doing all class today, what you've been doing in the article and the experiment writing, is you're going to go ahead and answer our investigation question. How can magnets cause objects to have kinetic energy? You are not required to use all of the words in the word bank, but I do recommend it, right? Try your best to use them all. It definitely is helpful to use the words because it helps you get some context as to what you should be talking about. But I want you to go ahead and give me at least 2 to 3 sentences, full sentences, answering this question. So for full credit, you do need to answer our investigation question right there using 2 to 3 full sentences with vocab. And one vocab word will not cut it. You should definitely try to use them all. I know all of you can do that because it's words that you are now aware of and that you know. So I want you to go ahead and pause the video. Take about 5 minutes to go ahead and answer this question for me. And when you're done, make sure you go ahead and hand it in right there. So go ahead and pause, take 5 minutes, go. Okay, so by now you should have finished our homework question, so you should have answered right here. What is our investigation question? How do magnets have kinetic energy? You use the word bank, great. The last part of our lesson today is always the exit ticket. So make sure that you click on the exit ticket. I want to encourage you to use the PowerPoint, use those resources for yourself when you're taking this, because I know some people have made some careless errors lately, but that's okay. So go ahead and complete that for me. If you have done the warm-up, the activity 2 writing, the activity 3 writing, the homework, and your exit ticket, those 5 parts, then you're good to go and you're done for the day. And you won't even have any science homework or work until next Tuesday. So remember that we don't have class tomorrow or Friday or Monday. And so I hope that you all have a really good 5-day weekend. Happy Easter break. I know that it's like a holiday, but just remember, please stay safe. Once again, let me know if you need anything. I'll be available, whether it's Thursday through Monday. I'm here to help, so just reach out if you need anything. And other than that, have a great rest of your day. Have a great spring break, and happy Easter. I'll see you back here on Tuesday.